PON, or Passive Optical Network, is a widely adopted technology for delivering high-speed broadband service over fiber optics networks. It utilizes fiber to transport high-speed digital signals, often between devices, using SerDes technology to manage and convert data stream efficiently. While PON is typically associated with broadband access, such as GPON or EPON, it can also be relevant to specific SerDes applications, particularly when fiber optics and high-speed data communication are essential. The combination of PON and SerDes is beneficial in cases where high-speed, long-distance data transport is needed, leveraging the high bandwidth and low signal degradation of fiber optics. PON enables high-speed internet with enough bandwidth to support both current and future broadband applications. Modern PON technologies, such as GPON, Gigabit Passive Optical Network, and NG-PON2, Next Generation PON2, provide gigabit level access, which is ideal for data-heavy service like high-definition video streaming and cloud applications. Newer standards like XG-PON and XGS-PON offer speeds up to 10 gigabit per second, making PON a highly future-proof solution. SerDes technology is used to convert pair data, which requires multiple connections, into high-speed CS data stream, which requires few connections, and back again. In high-bandwidth applications, such as data centers or long-distance communication, PON technology, for example, GPON, EPON, are used for delivering high-speed fiber optics connections. SerDes interface supports these connections by converting data to a CS format optimized for optical transmission, enabling efficient data transport across fiber networks. PON offers significantly lower latency compared to traditional copper networks because optical fibers transmit data at near light speed, reducing communication delays. This low latency is essential for real-time applications like online gaming, video conferencing, and other latency-sensitive services. With its high bandwidth and low latency, PON is ideal for fast, efficient data transport. SerDes technology complements PON by converting data to and from CS formats with minimal delay and high throughput. In systems such as telecom backhaul, data centers, and enterprise networks, PON and SerDes work together to enable smooth, high-speed data transmission across long distances with low latency. PON networks use optical fibers to deliver data to multiple endpoints, often sharing a single fiber among several users or devices. To handle large data volume efficiently, high-speed interfaces like SerDes are essential, as they convert data for optimal transmission over optical fibers. By enabling efficient signal processing and reducing the required bandwidth for each data transmission, SerDes help make the entire PON network more efficient. PON systems are highly scalable, capable of serving small areas like neighborhoods or expanding to cover cities and regions without major network overhauls. This scalability is achieved by using optical splitters to divide a single fiber signal into multiple paths, allowing broadband delivery to hundreds or even thousands of endpoints. SerDes technology enhances the scalability of PON networks by supporting faster data transmission and higher data rate, essential in systems like 10G PON or NG PON2, where speeds of 10 gigabit per second or more are needed. This makes PON ideal for large-scale applications such as cloud data centers, telecom infrastructure, and 5G networks, where high-speed data transmission is critical. PON networks are easy to maintain thanks to passive nature of the optical components, with fewer active elements that require power or measurement. The network is simpler and more reliable. The central equipment, known as optical line terminal or OLT, connects to multiple optical network terminals oriented through splitters. This design allows the OLT to handle issues from individual users or groups without disrupting the entire system. SerDes devices are often integrated into network equipment to convert data for fiber optic transmission. By combining PON for the network backbone with SerDes for efficient serious data communication, we can build a large, efficient, and reliable fiber optic system. This setup is particularly useful in applications where fiber optics form the backbone of the network, and the SerDes handles high-speed data transmission. PON is favored primarily for its cost-saving benefits in deploying fiber optic networks. In traditional fiber setup, each user needs to dedicate fiber link, which can be expensive to install and maintain. PON, on the other hand, allows multiple users to share a single fiber, dramatically reducing the amount of fiber and equipment needed. This makes it much more cost efficient, particularly for large-scale deployments like fiber to the home. In these environments, PON minimizes the need for expensive cabling and infrastructure, lowering deployment costs. When combined with SerDes technology, which enables high-speed data conversion, PON further reduces the need for multiple data paths. This makes PON-based SerDes system more scalable and easier to deploy than traditional point-to-point fiber connections, which would require more equipment and connections. PON networks are capable of supporting multiple services at once, such as voice, data, and video, making them ideal for broadband delivery. This capability allows a single connection to provide triple play service, voice, video, and data, to homes and business. As 5G, IoT, and cloud service demand high-speed data transmission over long distance, the combination of PON and SerDes become even more crucial. PON ensures the fiber to the home infrastructure, while SerDes efficiently shares data for rapid communication, enabling the high-speed performance needed for modern, data-intensive applications. PON networks are designed for energy efficiency, thanks to passive optical components like splitters that require no power, unlike the active components in traditional copper-based systems. This reduces operational energy costs and supports greener network deployments, which is essentially important in large-scale projects like smart cities and intensive broadband networks. SerDes technology in PON systems also contributes to power saving by converting bare data into series form. SerDes reduces the number of wires needed for data transmission, further lowering power consumption in network equipment. This is crucial for large-scale fiber optical networks, where both high performance and energy efficiency are essential for long-distance and high-speed communications. PON networks are more reliable than traditional copper-based systems because they use passive optical components, which have fewer failure points. Optical fibers are also more durable than copper and are immune to electromagnetic interference, enhancing both network reliability and performance. This makes PON ideal for both urban and rural areas, where reliability is crucial. Additionally, PON networks have a lower environmental impact. Fiber optics cables are more durable and require less maintenance than copper cables. This ability to share a single fiber among many users further reduces material usage, contributing to a smaller environmental footprint. Here are the summarized images showing you PON and SerDes are complementary technologies that work together to create high-speed, cost-effective optical networks. PON provides the infrastructure for fiber optic broadband, while SerDes ensures efficient data serialization and deserialization, enabling fast, low-latency communication. This combination supports high-performance systems like fiber to the home, data centers, telecom networks, and cloud service, offering scalability, efficiency, and reliable data transmission. Together, PON and SerDes are ideal for applications that require long distance, high bandwidth, and low latency communication. PON delivers scalability, energy efficiency, and low power consumption, while SerDes ensures fast data transmission with minimal loss over the fiber median. This powerful combination meets the needs of modern communication systems, including data centers, residential fiber deployments, and 5G backhaul networks. Thanks for watching. Before you go, if you are benefiting from those circuit images, I would love to hear your feedback and please share your comments down below. Lastly, please share the video link with the people who may be benefiting from it.